Welcome to PASC26. This is the highlights from the mini symposium. I'm here with Michael Sanowski and Ian Stormer, both from the Technical University of Munich, Germany. And you organized a symposium with the title From Physics to Data and Back, Trustworthy Machine Learning Potentials for Materials Design. So, Michael, what was this mini symposium about? Can you describe it a little bit, and where the idea comes from?
Yeah, so in general, in our field, we're working with machine learning potentials, which have a great promise of simulating much larger systems at also very large accuracies that before it wasn't even possible. And the problem here is that sometimes they under-deliver in terms of accuracy to experimental data. And in general, because these are black box methods, they're not always extremely trustworthy. So which is why we organize this mini symposium. It's also a big growing field with a lot of interest because it has a lot of big promises for a lot of developments in material design and many different areas. So, yeah.
So thank you. But then with many opportunities, there are always a lot of challenges, especially for a field that is growing. So in your view, also after the discussions that you were having in the mini symposium, what are the challenges that you have to face?
Yeah, one challenge is as already mentioned, the trustworthiness. We don't really know how good the predictions are that these models give us. So we had some speakers talk about uncertainty quantification to know, is this really the result, or is there a big uncertainty around it? That was one of the main questions asked in the mini symposium, but also other approaches taken.
So, but is it a general problem then whenever we want to apply these AI machine learning methods now to understand whether we can actually trust the results? Is this what the main discussion was about?
Yeah, that was a main part of the discussion, I would say, because if you run a simulation and you get a result and you don't know if this is what would actually come out, then.
But what are against what are you benchmarking to see whether the results are accurate and actually trustworthy?
Sorry. Yes. So a lot of the field revolves around density functional theory data, the quantum mechanics approach. That's sort of you could say, gold standard in that field. And the model is trained on that data, and you, of course, want to get as close to this data again as possible, and want to basically have a surrogate model that predicts what the quantum mechanical approach would do. But we also had some validation against experiments, so you can you sort of see both sides of the field from the very small to the very large, and have these models predict.
Very good. So you have means to actually validate and verify your models. That's very good. Okay, my final question is, of course, you have your mini symposium, you have had your discussions, some challenges to address, but what are the next steps? What would you like to see happening in the coming months after the conference?
I would say we hope to also get some collaborators to meet people who are working on similar things as us. So it would be also very nice to find people to collaborate with on very different projects. That I think would be very nice.
But are you going to ping the people that you met at the conference to sort of maintain the momentum and? Start also the collaborations. Yeah. You think this is the way to go?
Yeah, definitely. Yeah. We already had a coffee after the mini symposium, talked about some open challenges, what we could work together on.
Yeah.
Very good. So thank you very much. Then maybe I will see you again next year with the first new results, and maybe the next set of challenges. So thank you
That would
and
be great.
enjoy the conference.
Thank
Thank
you.
you.
Likewise.